Good day everyone, I'm Mary Stephen and today I'll be discussing the Spearman rock formation. But first, I will be introducing you what is the Spearman rock formation. So it is the non-parametric version of the Pearson R correlation. So this means that it is a statistical method that does not make assumptions about the underlying distribution of the data. Meaning it doesn't require the data to follow a specific pattern like a normal distribution. Instead, it analyzes the data based on ranks. Next is Spearman rank correlation coefficient, or also known as rho, which is when we word that is that looks like letter E, or also signified by R sub S, measures the strength and the direction of the association between two variables. So unlike in the Pearson R correlation when we compare raw values, here in Spearman raw correlation, it compares ranks. And finally, the correlation coefficient takes on values ranging between -1 and 1. So when getting the Spearman raw correlation value, our answer or the final answer should be within the -1 and +1 only. So here is the formula for the Spearman rank correlation. It is R sub S equal to 1 minus 6 summation of D squared over N multiplied by N squared minus 1, where R sub S, it is the Spearman's rank correlation. D meaning the difference between the pair of ranks of X and Y, and finally N, the number of pairs of ranks. So here's an example. A teacher wants to determine whether there is a correlation between students' study hours and their final exam scores. She records the number of hours studied and the corresponding exam scores for 7 students. Calculate the Spearman rank correlations and analyze the relationship. So here is the given values. So here are the first steps. So rank the scores. So first I'm going to create the table. In ranking the scores, we will divide it into 2 parts. So the first one will be the rank X. And the first values, so the study hours will be our X. So first, when we rank the values, the first rank is the lowest value into the X. So the lowest rank is 5. Will be the rank of this exam scores, which will be denoted as white, R white. Same for the RX, the lowest value will be our rank Now, after we'll get the rocks will be filled, the next step is to fill the table. Okay, so in getting the only thing we do is to subtract the Rx and the Ry. So, for example, the 6 minus 7 will be negative 1. 7 minus 4 is equal to 2. 4 minus 6 is equal to negative 2. 2 minus 2 is equal to 0. 3 minus 5 is equal to negative 2. 5 minus 1 is equal to 4. And 1 minus 3 is equal to negative 2. To get the D2, the only thing we do is to square the values that we get the D. So, for example, here is the negative 1, so negative 1 squared will be 1, 3 will be 9, negative 2 will be 4, 0 will be 0, negative 2 will be 4 again, 4 will be 16, and negative 2 will be 4 again. And after getting the 2, we will summation this, or we'll add this all to get the summation of b squared. So summation of b squared is equal to 38. So our next step will be substitute the values in the given formula. So the formula that we have will be r sub s is equal to 1 minus summation of b squared and n squared minus 1. So after getting the law, will be the next step is to determine the strength of the relationship. So we'll base on this table to get the relationship. So 0.01 to 0.98 will be none or very weak relationship up to the greater than or equal to 0.70, which will be this very strong relationship. So since our sub s or rho is equal to 0.32, and when we base this to the table, so the relationship that we can interpret is it is a moderate relationship. So here is our final answer. R sub s is equal to 0.32, and the interpretation would be the moderate relationship. So this means that the study hours and the exam scores have a moderate relationship. Next, we'll move to another example. A delivery service wants to know if there is a relationship between customer satisfaction ratings and the number of days taken for delivery. They collect data from 6 recent deliveries. Compute the Spearman transportation coefficient. Now here is the value. So first step is to run the score. So values on the given formula. Now, after solving the R sub S, so we determine the strength of the relationship. So based on the table, again, so since R sub S is equal to negative 1, so it belongs in the 0.70 above or the very strong relationship. So if our answer would be negative, so it is still the same very strong relationship, but it is negative, very strong negative relationship. Here's our final answer. R sub S is equal to negative 1, which is very strong negative relationship. Now let's move to another example. So our researcher wants to investigate whether age affects reaction time. She collects data from 6 individuals of different ages and measures the reaction times in milliseconds, determining the Spearman formation coefficient. Now here is the values for our problem or example number 3. Now we'll go to the first step, which will be ranking the scores and filling in the Now we'll be getting the D and A squared. Six minus 6, 0. 2 minus 5 is 3 minus 2, 1. And 1 minus 4 is 4. Now 3 squared is equal to 4. 3 squared squared is equal to 9. 0 squared will be zeros again. Negative 3 will be 9. 1 will be 1. And negative 3 will be 1 again. Now after getting the squared, we'll get the solution again. So now our next step will be substitute the values for the given formula for our S. So our sum is Spearman rule we will need to determine the strength of the relationship. So we'll base on this table again. So 0.09 will belong to the in this category or the correlation non or variable. Interpretation will be non-verbal relationship. So which means the age have no significant relationship to the reaction time of the person. Now we'll proceed to another example. A company wants to see if increasing its advertising budget leads to higher sales revenue. They collect data for 7 months and compare advertising expense with sales revenue to find the Spearman correlation. So here is the table. So the advertising budget will be per $1,000, and the sales revenue will also be based on per $1,000. So here are the steps. So wrap the scores and we fill in the table. no prompts for the values, so find the p. So the only thing we do is to minus or to get the subtraction of the Rx and R1. So 2 minus 7 will be negative 5. 6 minus 6 will be 0. 1 minus 1 will be 0. 5 minus 4 will be 1. 4 minus 5 will be negative 1. 3 minus 3 will be 0. And lastly, 7 minus 2 will be 5. So the next will be b squared. So negative 5 will be, negative 5 squared will be 25. 0 squared will be 0. 0 squared will be 0 again. 1 squared will be 1. Negative 1 will be positive 1. 0 squared will be 0. And 5 squared will be 25. Now, after getting these values, we'll have to add this to get the summation. So, summation of b squared will be 52. Now, after getting this, or after filling the table, we'll be solving for the RS. So our Spearman correlation will be 0.07. So after getting this, we'll determine the strength of the relationship. And by basing on this table, so we can conclude that 0.07 will be in this category. And the interpretation will be none or paired with each relationship. So 0.07 is or have a non or variable interpretation to our example. So next we'll proceed to the final example. A social media influencer wants to determine if there is a correlation between the number of followers and the engagement rate, which is the likes and the comments per post. The data for 6 influencers is given below. Calculate the Spearman correlation. So here is the values for our table. So again, the first step is to rank the scores and to fill the table. square is values that we have in D. So -3 will be 9, 1 will be 1, 1 will be 1 again, another 1, -2 squared will be 4, +4, and 2 will be +4 again. Now after getting the D squared, we'll add these values to get the summation of D squared. So the summation of D squared is equal to 20. Now after filling the values for the table, we'll find the substitute the values on the given formula. So the given formula will be Rs or R sub S is equal to 1 minus 6. The summation of D squared is equal to divided by n squared minus 1. Divided by 2, that will be 0.57. And 1 minus 0.57 will be 0. Now after getting the product, we'll determine the strength of the relationship. Now the 0.43 belongs to the category here, which interprets that the 0.43 will have a strong relationship. So 0.43 has a strong relationship. And now we're done with our topic for today. Here are the references if you want to go deeper into the topics. And I hope that you learned something new. And that's all for today. And bye bye.